So we graphed our exponential growth function, had to change the window to a Y max of 10,000 to even get close to this thing. Besides hitting trace and typing a 6 enter to get the Y value, what is another thing I could have done? Somewhere back here on the home screen. Anything I could have done here? Yes, I could have just typed it. We could get the same thing that way too, since we had the equation. So we could use the graph, or we could use the home screen on that one. Good thing I'm doing your homework with you. So we had our initial bacteria. You guys said that was 100. That is now. We call this the initial number. What do they call it on the street? What do they call that value on the street? When you hit the trace and type a 0. What are they called? They call it a Y-intercept, don't they? Okay. So the Y-intercept is the value right there. How many bacteria are present after 6 hours? Well, that's the 6394.35. Sure, we probably have to round up or down so that we didn't hurt the feelings of that last bacteria. Okay, let's move on and take some notes. Yes! Sometime after now. So, how are those tests looking? Well, they're white with some pencil writing and some black ink. Some of them have some red on. I've got one more page that I'm working on, and then some of you are not finished or haven't taken it yet. So, those kind of things. Alright, so we've got this exponential function, and we need to talk about it, kind of, take that trip down memory lane. Since we beat this into the ground last year in Algebra 2, the A value, we said that was your Y-intercept. Story problems love to refer to it as the initial amount. It could be the amount of money you started with, could be the population size. The other day, one of my, at parent-teacher conferences, one of my parents, mentioned the fact that their job is to deal with drug tests. And in those drug tests, they have to study half-lives. Half-lives of things like cocaine and heroin and marijuana. Okay? And they have to do those phone calls. Hey, you failed. Therefore, you don't get the job. Those kind of things. Surprisingly, some of those drugs can leave your system in a hurry. Right? They have half-lives of like 2 hours. They keep getting cut in half rather quickly, which is why people get addicted to them, because they keep upping the dosage and they have to keep going back to it to get what they're wanting. Okay, but half-lives happen all the time with pharmaceutical and non-pharmaceutical drugs. which is why some of your medications, if they're on the shelf too long, they lose their effectiveness. You might as well throw them out because they're not going to help take care of the pain or help do the job they're supposed to if they're not used, if it's not like a daily medicine that you have to take.
Do you die from medicine?
I really don't think so. Unless it's, been coated in something poisonous. Okay, not trying to give you any ideas here, okay, folks? We're not doing that. Okay, the B value is what we call the growth factor. And that growth factor can take on values larger than 1, and it can take on values between 0 and 1. Now, if it's a value greater than 1, what word do we use? Growth or decay? This is growth. Obviously, that would mean this is decay. I hesitate saying smaller than 1, and the reason I don't like saying smaller than 1 is that some people think that a negative number is possible. It's not possible. You're not getting a negative B value right here. It says very clearly that B has to be a positive number. Okay, what else do we know about A? What if A was 0? What if A was 0 and you were on the operating table? You ain't coming back, folks. If A is equal to 0, that's what we call flatlining it. Right? Because it wipes out the entire function, makes it a horizontal line. It's not good. So A is not going to be 0. If A was 0, we would call that a showstopper. Okay, let's see, what else do I need to say about this basic function? What do you notice about the exponent? Exponent is a variable. Now, for those of you who don't know, a variable can take on many different values. And if you don't know that, I'm really concerned. B is a fixed number. Do you understand what I mean by a fixed number? It's not changing in the problem that you're dealing with. It will not be different. But your variable, yes, that's something that can change. Why do I make a big deal out of that? Well, it says that I have to identify whether something is an exponential function or not. Do you know if this thing is an exponential function? It is? Okay. If it is, tell me what the initial value is. What's the y-intercept? I got to vote for 1. Okay, it's concerning to me for a couple different reasons. One, it's the number where the red arrow is pointed at, which is in front of the 3 button. Secondly, some of you did not know how to find y-intercepts on your test. How do you find any y-intercept in the universe? You plug in what for x? 0. That's pretty simple, right? We've been doing that for a very long time. Whether we're talking about quadratics or polynomials or linear functions, it doesn't matter what kind of function it is. If you want a y-intercept, plug in 0 for x. And what is 3 to the 0 power, by the way? Ouch. 3 to the 0. 1, thank you. Anything to the 0 power. Now, if you don't believe me, what is 3 to the 5th over 3 to the 5th? Anything divided by itself? 1, right? Now, what are you allowed to do with this exponent and this exponent? Subtract. Sorry, that is a bad choice of color on top of a blue background. 3 to the 5 minus 5. That is 3 to the 0. So, anything to the 0 power is 1. Don't sit there and try to argue with me about 0 to 0 power, Mr. Stanley. Okay? How about letter B here? G of x. Does that fit the exponential model? No. Look, it's got a fixed exponent and a variable base. That definitely doesn't fit the category. What about this one? Sure it does. Now, is this exponential growth or decay? Growth, okay. Now, you got 30 seconds to talk to your neighbors and figure out what the heck's going on with this thing right here. I suggest maybe a little fireproof form. Talk amongst your neighbors. There are 2 things you better be telling me right now. And then we'll discuss the graph. Go. Okay, so hopefully you divided by -2 on both sides. So you saw what 2 things happened. We got a reflection, right? We got a reflection across what? Across the x-axis, that's true. And what else do we have? Vertical stretch by 2. Yep, that's it. 2 things going on. What does that mean about the graph? We started out with, you guys told me that we were dealing with good old exponential growth. But if we know that it's got to have a vertical stretch of 2 and reflected across the x-axis, what's it going to be looking like? Let's just say you don't want your money to do this. Well, no, it's worse than decay. Double decay? Okay. Yeah, this is federal government kind of stuff here. Yeah, this is money dropping off the face of the earth, and you keep taking more, and somebody's stupid enough to give you more kind of stuff. Okay? Yep. Okay, these kind of questions in example 2, you need to be able to do these without a machine. Okay? 4th power. You should be able to tell me that's 16. 2 to the 0 power. You should be able to tell me that's a 1. Now I will say when you get to part C and I ask you to plug in a -3, we're using your Algebra 2 skills. I would want you to stop right about here if you didn't have a calculator. If you could go to 0.125, okay, fantastic. But, if you gave me 1/8, I'd be happy with that. So, what if I asked you to plug in... What if I asked you to plug in... What do they got on my list? Oh, a fraction. Yes, you will have to remember that a fractional exponent is the same thing as a radical. And that's where I would want you to stop there. I don't expect you to know that radical 2 is 1.414. And then what happens when you have that whole negative fractional exponent? So, what does the negative tell you to do? What does the negative tell me to do? What am I supposed to do with this thing? To get rid of the negative. We push it to the denominator, right? And then I tried to teach you or remind you that a fractional exponent is the same thing as power over the root. So I would expect you to be able to do this. And here's where we could just stop that whole train. Those are basic algebra skills. We're not expecting you to move mountains. Rationalizing denominators, simplifying radicals, we're okay without doing that. But I want to be able to see that you can use your algebraic properties. So hopefully some of you are paying attention, because it seems like I'm losing a few of you to the dark side of the web. I'm like, come on, stay with me here. Okay, example 3 here. Determine formulas for the exponential functions g and h whose values are given in table 3.2. Alright, so g of x, let's see, we want something times something to the x power. What do you think we're multiplying by every time? We're looking at g. What do you think we're multiplying by every single time? Thank you very much for the vote for 3. You would be correct. What do you think goes in that first blank? Okay, so what did we call this thing? In a story problem, we called it the initial value. On a graph, we said it represents what? The y-intercept. Do or have we been given the y-intercept? Thank you very much. Somebody's paying attention. Hey, look, there's the y-intercept for... Okay, so you guys figure out each. notes here. 8 was right there, and we were multiplying every single time by a quarter. Well, if only there were homework problems just like those. How about question 11? Alright, so let's see. Okay, question 11. So f of x equals something times something to the x power. What's our initial value? Our initial value is 3 over 2. Better question is, what are we multiplying by each time? So we're going from 6 to 3 to 3 halves to 3 quarters to 3 eighths. There's no way we can be multiplying by 2 every time. It is 1 half that you're multiplying by every time. So if you had this, you are correct for question 11. Okay? Do question 12. Find g of x. So what's your starting amount? 12. What's your multiplier? 1/3. Okay. Quick question, not on this, because I know you need to practice. See, every year I find out that, or I talk to kids about percentage growth, percentage increase, percentage loss. People, we don't start with percentages at 0. We start with percentages at 100%. And we go up or down from that number. Now, would you say that both of these equations are growth or decay? You should say that they're both decay, because their growth factors are between 0 and 1. The question is, what percentage? So both of these are going down. What percentage loss do we have? Okay, so if we start at 100%, and this says that we are going down to 50%, how much did we lose? We lost 50%, so that's a 50% loss. Or 50% decrease. Alright, what about the next one? We're going from 100% down to 33 1/3%. And out of room for my percentage sign. What did we lose? What percentage loss are we talking about here? Ooh, yes, 66.7%. is one people say all the time. I hear it all the time. Going down the hallway, people are talking 2/3 all the time. It's ridiculous. Okay? You should just say 2/3 and be done. I don't get it. Wasted effort. Okay. This is all information we've already just discussed about growth factors, using the word growth and decay. So that's nothing new. Folks, yes, you should be able to analyze these things. You should be able to find the domains and ranges of these things. What is noticeably missing about these? Does this have any vertical asymptotes? No. How do you know that they don't have vertical asymptotes? Because vertical asymptotes come from the what? Denominator. We don't have a variable denominator. We have one about this. They're continuous functions. Do they have horizontal asymptote? What's the horizontal asymptote? Y equals 0. Yes, I think we refer to as the x-axis. Y equals 0. Take this exponential decay function. What's the limit as x goes to negative infinity? Thank you very much. Infinity. What's the limit as x goes to positive infinity? 0. Yeah, you need to know your limits of your indicator. Oh, all that good stuff. Is the limit as you go to the right for a long way of the exponential decay function? See how it's getting closer and closer to 0 as you go this way? I mean, that's different, obviously, from this one. Go to the right on this one. Gotta go to the bottom. Yes, you need to know that. Okay? Now, don't pack up on me here. I need to go through these 4 examples with you. Okay? We need to change these to fireproof form. Now, some of you, at least from my other class period, if this is your original function right here, what does fireproof form look like for that? Y minus k over b equals 2 to the x minus h over a power. These functions a, b, c, and d are pretty simple. In fact, they have, I think, one change in each one. So, getting them into fireproof form in some cases is extremely boring. Some of them, like letter A, are already in that form. What would you say is going on with letter A? You've got to use words like left, shifting left, right, up, down, stretching, shrinking, vertical, stretch, horizontal, stretch, reflection. What do you got for me? This is right 1 unit. I didn't have to do anything because it already was in the form I needed it in. Now, some of you are not going to recognize this next one unless you do a little bit of algebra. Now, 0.5, oops, sorry. Oh, don't you dare do this to me.
Teacher students will sad for the interruption.
Yeah, right.
Great council here at the end of the day. Speech and debate. Teams will be held in the community room instead of room 900 tonight. Just one last minute change. So again, speech and debate team.
Say it again.
You're going to meet in the community room over the 10th wall side instead of room 900. Thank you.
All right. We should extend the school day whenever he does that. Hey, something would get changed if that happened, right? Because there'd be some angry kids, right? Petitions would be flying everywhere. Now, what would you multiply the 1/2 x by to change it into 1x? I taught you how to do this trick a long time ago. What would you do to multiply 0.5x and change it into 1x? You would probably 2. You would multiply by 2. It's 1/2. Okay, it's not 5. Oh, you're hurting me, folks. Hurting me. Okay, now, so this h of x is really y equals 2 to the x over 2 power. Can you describe what's going on? You should be able to tell me. This is a horizontal what? Horizontal stretch of 2. Yeah, the change is happening on the horizontal to the x value. Okay, got 2 more. Okay, so this is similar to what we've done before. Now it's in fireproof form. Tell me what happened. That's a vertical stretch of 3. Over here, we move it over to the other side by subtraction. Tell me what happened. That is up 1 unit. Shifting up 1 unit. Obviously, we will probably combine a few things, not just one. I probably won't go crazy and have, 5 different things, but I might have 2 or 3 max. All you have to do is put, is there a sub down there?
Yeah.
Ah, okay. You're a good kid. It won't matter. Tell me, do you know this cool number? This is E, right? So what does that say? Yes, which means when you come through my door tomorrow and look at the wall, you'll actually understand what it says.